Hello again. In this video, we're going to talk about nomenclature. Okay, what does that mean? That means how to name all of these compounds. Nomenclature. This is an L. All right, nomenclature. So, first we need to figure out, is it ionic or is it covalent? Remember, each of these have different rules associated to them. So let's look at several examples here. How about we have strontium, Sr, which is group 2A, so it's going to be strontium plus 2, and we have oxygen, the charge of -2. All right, well, our formula is going to be SRO. This is ionic, obviously, so we have no prefixes whatsoever, and this will just be strontium oxide, and there's our name. All right, look at another example, K, and iodine, potassium and iodine. Potassium, group 1A, iodine, group 7A. Big difference in electronegativity. Obviously, it's going to be ionic. Potassium is in group 1A, iodine is in group 7A. Formula is going to be Ki. This is ionic because of the big difference in electronegativities, and this is going to be potassium iodide. Iodine, chop off the ending, add IDE, iodide. That's how we get the name of the anions here, the negative ions in these compounds. Positive ions, we just use the elemental name. The negative ions, the anions, we chop off the ending and add IDE, as you've been seeing in these particular examples. Let's take a look at another one. Let's try one that will need the stock system. So transition metal, how about iron with a charge of +2? And finally, let's go back to oxygen. Actually, let's change this. Let's go to iron 3. Let's give iron 3 a try and get a different formulas than some of the other examples we've been seeing. So we have iron 3 +3 and oxygen -2. We swap, we use that crisscross method, and we get a formula of Fe2O3. Okay. We look at these electronegativities, we'll see that this is definitely going to be an ionic compound. Electronegativity of iron somewhere around 1.6, oxygen 3.5, definitely going to be an ionic compound. But we can just generalize it too with the space between them on the periodic table. They're very far away. So if we have a metal and a non-metal bonding together, it's likely going to be ionic. If we have two non-metals bonding together, likely going to be covalent. So what's the name of this? Well, remember the transition metals, all the transition metals we need to use the stock system of chemical nomenclature. So we use the name of the metal, in this case iron, and in Roman numerals we're going to put the charge on it. The charge is +3. And remember that in Roman numerals it's not the number of iron atoms or iron ions in this case. It's not going to be 2, it's the charge +3. And finally oxygen, chop off the ending, add IDE, oxide. All right, let's take a look at some examples of covalence. Let's look at NO, N2O, and NO2. Okay, these are all nonmetals bonding with nonmetals. Electronegativities are very close together, so they're all going to be covalent. All right, now the first element, we use the name nitrogen. Okay, and if there's more than one of the first element, we need a prefix. Remember, mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6. We see there's only one nitrogen in NO, So we do not need a prefix at all for it. And the second element, oxygen, always gets a prefix. Chop off the ending at IDE, monoxide. N2O, there are two N's here. Di for 2, nitrogen. And again, there's only one oxygen, so monoxide. NO2, there's only one nitrogen, so back it's not mononitrogen. Only if there's more than one do we use a prefix for the first element. And finally, oxygen, chop off the ending at IDE, oxide. All right, so those are some examples. Let's take a look at some of the polyatomics then that you might run into, because you will be learning about those in this particular module. Okay, so let me just scroll this down a little bit. We'll go back to ionics, but with polyatomics. All right, how about sodium, a group 1A metal, and how about the polyatomic hydroxide? Okay, group 1A, that's +1 for sodium, -1 for hydroxide. The formula here is going to be NaOH. And we use just like before, the cation is going to be the name of the element. And with polyatomics, we're just going to use the name of the polyatomic. OH- is called hydroxide. That's its name. And we're going to use it. We don't change it at all. Okay. Let's look at one other. How about sodium again and sulfate? Okay, well, +1 here, -2 here. We do the X method. We can do that for polyatomics as well. That's going to give us 2 NAs and 1 SO4. And remember, this is an ionic compound as well, so we do not need prefixes. It's still going to be sodium. And in this case, SO4 is sulfate. We just use the name. Let's see if I have any more space. I don't. Let me just clear this, and I want to do one more. Because a lot of students have problems with this. Let's say we have let's try a stock system name with a polyatomic. How about copper with a +2 charge and hydroxide? Okay, and this will be our last example. Copper with a +2 charge. Well, we swap these numbers. Remember, this is -1, so we're going to have 1 copper and 2 hydroxides. And in this case, when writing the formula, in order to show more than one of a polyatomic, we need to put the polyatomic in parentheses. That's the only time we put polyatomics in parentheses, when there's going to be more than one in the formula. And in this case, we need 2 hydroxides. Why? Because we need the charges to even up. Copper's +2, hydroxide is only -1. We need 2 hydroxides for a total of -2 to cancel out that charge from copper, giving us a neutral compound. And this is going to be, in stock system, we have copper, the name of the metal. Oop, my pen just went to eraser again. And the charge is +2, copper 2. And finally, just use the name of the polyatomic, copper 2 hydroxide. Hopefully this little tutorial on the naming of both covalence and ionics will help you through the module.